Hi, here I'll be presenting, describing, and demonstrating the location-aware media player. The purpose of the project was to create a media player that could determine and report its geographical position, download relevant files, and display them. Secondary objectives included keeping production costs low and minimizing bandwidth utilization. From the onset, we determined that the most direct and cost-effective approach would be to base the solution on the Raspberry Pi platform, tying in a GPS module, a 3G broadband connection dongle, and a powered USB hub in order to provide enough current for the 3G transmitter. A server component would be required as well to provide location-based media files. Though the server side of the equation was not actually covered by the scope of the project, it was necessary to design an API and data structures that would allow the remote players to understand the eventual server. In order to allow for flexibility and power, a system was created which defined a number of geozones centered on some specific coordinates, each of which would be associated to one of many schedules. Now, each schedule has one or more playlists, each playlist has an ordered set of media files, and each file has some specific video content. This organization gives us great flexibility while limiting the amount of downloading required by the mobile clients. Here is an example of what the server-side database might contain. There are a few geozones defined, each of which has a schedule assigned at any given moment. Depending on the time of day, the schedule knows which is the current playlist, and each playlist can point to any of the media files uploaded to the system. The mobile client is smart enough to download any files it hasn't yet cached, but only needs to download each file once, no matter how many playlists it may be included in. I find it impossible to deliver an incomplete solution, so even though it wasn't actually in the project scope, I created a functional reference backend for the server. It includes an administration interface that allows for management of the schedules, playlists, and media files through a simple web-based interface. Also, since the media players provide their identification and location to the server, it also logs each query for future use. The API, which allows for communication between the mobile clients and server, is a simple RESTful interface using HTTP GETs and POSTs that returns JSON content. Here I'm using a browser to retrieve the schedule and playlist data so you can have an idea what it looks like. On the client side, the mobile players are Raspberry Pi based. The Raspberry Pi B+, the most recent version of the hardware, was selected because it provides more RAM, a camera connector, and other nice features. The expansion board designed is, however, compatible with older Pis as well. For the GPS, the Adafruit Ultimate GPS Breakout was selected for a number of reasons, including the simplicity of interfacing and interacting with it, the fact we can power it from both voltages used on the Pi, because it can track up to 22 satellites on 66 channels and give us updates 10 times a second. It has an onboard antenna as well as a connector for an external antenna if needed. There's a connector for an optional CR1220 coin cell to use to back up the RTC and allow warm starts. It costs about half the price of the last Trimble-based module I used while giving very decent performance. In order to put all these components together, a custom Raspberry Pi Shield-type printed circuit board was designed. Two versions were created, a production board that is ready for fabrication, and a slightly simpler version that was built in-house for beta testing. The circuit board was used with the Raspberry Pi Plus, but should be compatible with all versions of the Pi. Includes a GPS header to connect the Adafruit GPS, either onboard or using an extension to allow the onboard antenna a view of the sky. Has circuitry that provides the equivalent of a powered USB hub for connecting the power-hungry 3G dongle, has an independent 5-volt input for high current power supplies, is designed with the new Raspberry Pi hat standard, i.e. hardware attached on top, the equivalent of an Arduino Shield, and is laid out to support the auto-identification and configuration EEPROM. The production version also supports an additional voltage regulator to allow the entire system to be powered from anything between 6.5 to 25 volts, so we can tap directly into a vehicle's 12V. The beta version of the printed circuit board was made in-house using a toner transfer technique. It's identical to the production version, but for the regulated voltage supply input, which wasn't needed here as a 5-volt 2-amp supply was used. The first time the media player is run, it will detect that it hasn't been configured yet and automatically launch this configuration interface. The simple text-based GUI allows you to enter identification and connection information for the device, namely where to connect so it can speak with the server side. Once the information is recorded, the system will allow you to load the configuration for 10 seconds after booting up, and will then proceed to run normally. During standard operation, the application is comprised of 4 threads that run concurrently. A positioning thread communicates over the serial line with the GPS and keeps track of the current position. Another thread is devoted to downloading new video content from the server, and one more takes care of actually playing the videos through the HDMI connector. The main thread handles communication with the server and is responsible for feeding jobs to the other threads. The video player executable handles a number of different formats, including MP4, Flash, and more. The videos shown here were all originally Flash files, and even so look pretty good. It's interesting to note that if your display supports it, sound will also be transferred through the HDMI connection. Well, this concludes the presentation and demonstration of the Location-Aware Media Player project. I hope you enjoyed it and won't hesitate to get in touch with any questions or comments. Cheers!